All right, so here we are going to still look at graphing in slope-intercept form. And remember, slope-intercept form is in the form of y equals mx plus b, where m is the slope, which, as we have talked about earlier, is rise over run. Or if we want to go ahead and use the slope formula, it's y2 minus y1 over x2 minus x1. So if we're giving two different points, we subtract the y's over subtract the x's. The b of our equation is the y-intercept in the form of 0, comma y, where y is the number that's given with the b. And it also, your y takes on the sign of b. So if b is plus b, it's a positive. And if b is a minus b, it's a negative. Okay? So if I have an equation in the form of y is equal to 3/8 x minus 4, right? Remember that my slope, my m, is already solved for me. My m is 3/8. All right, and my y-intercept, my b, is 0, comma, and the sign goes with it, so -4. Right? So we're going to look at a couple more examples today to go ahead and reinforce the idea of using slope-intercept form. All right, so here I have y is equal to 1/2 x minus 1/2. And as much as we hate fractions, this is not actually too bad. The best idea is to go ahead and scale your graph accordingly. Now I see that, first of all, my slope is 1/2, and my y-intercept is 0, -1/2, okay? And so I know that I'm going to go ahead and have to graph in halves, which is totally acceptable and totally something you should expect to be able to do. And so what I went ahead and did is scaled my graph accordingly. So rather than making every hash mark 1, every other hash mark is 1. So, and I marked them separately. So notice the shorter ones here. The shorter ones are 1/2. And then the longer ones are 1. And also I have marked them so that you know exactly what I'm doing with my graph. So you're not surprised when I graph something. All right. So the first thing I want to do is I want to go ahead and graph my y-intercept. My y-intercept is 0, -1/2. So I'm not traveling on the x-axis. I'm going down to -1/2, and I'm putting my first mark. Now my slope is 1/2. So therefore my slope is rise over run, which means I need to rise up 1 and then run 2 from my original point. Okay, my hashtags are now in halves, so I have to rise up a total of 1. So if I go up from -1/2 to the origin, that's only 1/2. In order to actually rise up 1, I have to go to +1/2. All right, so you have to go up a total of 1, but I'm starting at 1/2, and it's kind of awkward and takes a little bit of practice, but it's okay to do. And then I need to run 2. That's easy enough. So once I'm there, go 1, 2, put my second point, and from there I go ahead and graph. All right. So if you are going in halves, you got to be really careful. If I'm rising up a total of 1, okay, that is equal to 2 halves, or 2/2. So when you're doing ones, you got to be really careful. Similarly, if I were to go ahead and say, okay, well, my slope is still 1/2. Okay. and my b is negative 3 halves. Okay, let's even go even better. Let's go ahead and get really fancy with this, and let's, be realistic and say, okay, my slope is negative 1/2. Okay, so I'm going to go ahead and switch this color to green. My slope, my y-intercept, is 0, negative 3/2. Okay, so 3/2 is equivalent to negative 1 1/2. So negative 1 1/2 is where I'm starting from. And remember, my slope is negative 1/2. So if I go ahead, I can also consider my slope to be equal to 1 over negative 2. So I would rise up 1 and then go to the left 2. So if I'm rising up 1, I end up at negative 1/2. And if I go to the left 2, I end up there, and my line ends up going down. Now look at the idea of my slopes. My slope for the first line, for the blue line, was positive 1/2, which means it should go up from left to right. And my line does, so I'm okay. If I look at my second slope, it's negative 1/2, which means it should go down from left to right, and it does that. So make sure you're paying a special attention to the direction of your line to make sure that you are actually graphing your line correctly. All right? But what happens here if you're given a line in standard form, but asked to graph it in with using your slope and your y-intercept? So let's say I'm given something like this, okay? So I'm asked to graph it using, specifically, I'm saying I have to use the slope and the y-intercept, which I'm abbreviating. Okay. The easiest way to get that is to go ahead and solve this for y. And I understand that's not exactly everybody's favorite way to do it, but this happens to us. So if I am required by the graph to go ahead and do this, I have to do it this way. I'm not given a choice. That means I have to go ahead and solve my standard form equation and put it in the form of y equals mx plus b, and that'll give me everything I need to do. All right. So the first thing I want to do is solve for y, which means I need to go ahead and subtract my 5x over to the other side. Okay, so remember, this is just like solving equations, and I want to move my 5x over to the other side. This will cancel out, and I'm left with negative 3y. And remember, I want my x term in the front now, so I have negative 5x minus 15. In order to solve for y, I need to divide everything by negative 3. Right? That's going to solve this for y. A negative over negative is a positive, so I have 5 over 3x. Negative over negative is also a plus, and 15 divided by 3 is 5. So this line would have a slope of 5 over 3 and a y-intercept of 0, 5. Let's go ahead and look at one concrete example and graph it, and we'll go from there. Okay, so here I have 3x minus 4y is equal to negative 24. I am required to use the slope and the y-intercept to graph this line. which means I need to go ahead and solve it for y. In order to solve for y, I need to go ahead and subtract 3x from both sides. And remember, my goal is in the form of y equals mx plus b. I subtract that, I end up with negative 4y is equal to, now I can't combine these two things, 3x and negative 24 are not the same, but I need my x in the front, so I have negative 3x minus 24. From here, I go ahead and get rid of the coefficient and the sign in front of the y by dividing by negative 4. Okay, which leaves me with y is equal to, now a negative over negative is a positive. I have 3 over 4x. And a negative over negative is a plus. 24 divided by 4 is 6. All right. And my graph here is just marked. I just have it as a standard graph. I can change this and mark it by halves or fours. Okay, whichever I would like to do. Okay. I'm going to go ahead and mark my graph by halves. So I'm going to say this is 1, 2, 3. And I'm going to mark everything on the same. So negative 1 here, negative 2, negative 3. So I'm just separating it by halves. And I know, yes, I'm going to have something by force. But let's go ahead and work with this. All right. And I may need to extend this a little bit because I have a y-intercept of 0, 6. Okay. So maybe this is not the best way to go ahead and graph this, even though I was thinking I maybe needed to make it into halves. Maybe I just need to keep it as ones, because remember, this is talking my slope. So I start off with 0, 6. So I'm going to keep it by ones. And I'm running out of graph at the top, so I'm going to go ahead and use my trick that positive 3 over 4 is the same thing as negative 3 over negative 4. And we had talked about this in the previous video. And so instead of rising and going to the right, I'm going to go down and go to the left. Okay, so from my point, I'm going to go down 3. Okay, and I'm going to go to the left 4. And that will be where my other point is. And I should be able to go ahead and just connect those and get a nice straight line. Okay. Now my slope in my y-intercept was positive. My slope is going up, my line is going up from left to right. So it's definitely a positive line, so I should be okay. Right? So we're going to be going ahead and doing several problems of this kind where you have to kind of decide how you want to scale and how you want to go ahead and navigate. And so go ahead and try the problems I'm giving you, and I will see you in the next video.